Welcome to Diving Deeper Discussions in the ASA. This is our monthly event. I'm your guest host this month. My name is John Wood. I'm now the one of the two emeritus executive directors of the ASA, and just happy to be with you today. This Diving Deeper Discussions happens on the second Saturday of every month, and Randy Isaac is our host. And Randy happens to be one of the authors of the paper today, and he and Stephen Freeland are with us. Welcome to the two of you. And,
thank you.
And Randy is the typical host, and he will be back in the chair on the mic next month in that familiar role. But today I'm filling in and fielding questions so that Randy and Stephen are free to interact with you. We're looking at the paper Rethinking Abiogenesis. This is part 3 in a series, Meaning in the Light of Complexity, Information, and Simplification. And the Diving Deeper discussions feature these perspectives in the Science and Christian Faith articles, and an opportunity to meet the authors and to get in depth in the conversation. And that's where we're going today. So thank you all for being here. I want us to start with normally we start with backgrounds and bios. Randy and Stephen, you've both been on these discussions in the past, so you're ASA members and familiar to the majority of the audience. And so we will skip over those biographical features and get right to the discussion. And if you would open us up with a bit of a background, I'm just thinking about, this is such an interesting area. It's a deep academic subject that many people never think about. They can barely get their mind around abiogenesis. What in the world is that? But how did you get into this subject? And how did this in particular, the 3 papers, but specifically this last paper, and tell us a bit about that, if you would.
Randy, would you like to lead off?
Go ahead. No, because you had the inspiration. You were the leader of this. You've got to take all the blame.
All right. I'll keep it as brief as I can. And Randy's under strict instructions here and later on to tell me when I'm talking too much, right? So look, the simple answer is abiogenesis is what I do in that little fraction of my life that is a research scientist. To be fair, I do something one step beyond abiogenesis, but I'm part of the abiogenesis community. So a really simple answer is that as an ASA member, it felt appropriate to bring the current science before this body of people. I freely admit that part 1 was exploring an idea which is not mainstream in abiogenesis, but it's what I think is exciting and coming up. Part 2 was an extension of that. And with part 3, and here's where I get to hand over to Randy, Randy helped me understand that ideas we talked about weren't overlapped with, but were not yet expressed clearly in terms of really important ideas that he was much more familiar with from computer science, from engineering, from physics. And so part 3 was an attempt to connect with that language, that ideas, those literature. Randy, what would you add?
Okay, let me give a little bit more background of your role, Steve, because our history harkens back to the 2012 annual meeting in Point Loma. That's when I had invited some of the speakers to come from the intelligent design community, and I was giving a talk on information and on the origin of life. And I had heard rumors that there was someone named Steve Freeland living in Hawaii, no less, that was kind of one of the actual origin of life researchers around. So I did manage to contact him and invited him to give a talk, and we got to know each other. He did come to the meeting, gave a great talk, and we ended up working on a couple of papers that were published back to back in one of the issues of the journal. I forgot which one, in December of either 2011 or 2012. And that's where I got to know Steve and began a friendship that has continued to this day, and I greatly value it. I've learned so much from Steve. He's been a driving force in many aspects. I was totally flattered, and I forgot which year it was, Steve, but Steve was the organizer and the head of a Gordon Research Conference on the topic of the origin of life. And he was, where was that? Was in Texas, wasn't it, Steve? It was
Galveston. That's where they.
Galveston. That's right. We went to Galveston, and I had a great time. It was really super to be mingling for a few days with the actual origin of life researchers. And so I learned so much there and kept going with Steve. Then we had a number of conversations, I don't remember, and suddenly out comes this Abiogenesis Part 1. And I said, Steve, you didn't discuss that with me. That's really good. It's very interesting. And he says, yeah, but I wasn't sure if you had to be out of the loop in case of reviews or something. And I said, nah, you don't need to worry about that. I like this stuff. So we talked about what I considered to be a rather novel idea in directions, but his focus on continuity and time. And I said, well, next time when you do your next part, at least let me comment on it. And he says, well, why don't you be a co-author? I said, no way. I said, I'm not contributing anything here. And so we went through a few iterations. He sent me a draft of Part 2, and I edited enough until Steve finally said, you have made enough contribution that you ought to be a co-author. And I objected at first, but finally relented, which is why I got on Part 2. So for those of you who haven't reread it recently, Part 1 focused on continuity and time over in the abiogenesis and the evolutionary time frame, and Part 2 expanded that to continuity with the environment in space as well as time, if you will, and gave it coherent. And I managed to smuggle some of my pet topics in there on information and so on. And I think I overdid it because the reviewers, I forgot who suggested, but oh no, this whole chunk that I had written was supposed to be taken out of the paper and reserved for a different occasion. I think I managed to keep a little bit in it, but so I was supposed to do more on information separately. And then in response to Part 2, a lot of you gave feedback, but a lot of the feedback that you all sent was that we hadn't really explained what we meant by complexity, because we were talking about complexity there, but we hadn't really discussed it. And so that really got us involved in thinking about how to articulate complexity and what it all meant. And Emily Boring, who was the co-author on Part 2, begged off because she was getting into her studies and wouldn't be able to spend time with it. So that's kind of evolves the evolution of these three parts. But looking back, it does kind of come together, and I'm really excited now to have this kind of article that I hope gives some clarity to what we meant by the complexity. And this was a process of me learning from Steve. Steve, of course, is the brains behind this whole piece, and all the errors are mine, and all the good ideas are his, and we try to get it out in that way. So that's kind of the background of how I got involved, John.
Very good, Randy and Stephen. Thank you. That gives us a little thumbnail and a starting place for our conversation today as we enter. I can tell you, in that 4-day trip with my son that I took here just recently, he's an undergraduate chemistry major, thinking about your paper and thinking about this kind of reversal that you talk about, of going from life being actually a simplification. That's just sort of mind-boggling and in common sense terms. So, but just to say that's why we appreciate so much you're writing these papers, because it takes what is going on conversations in the academic world and in some very isolated communities and starts to bring that down and bring it into our community, and that just begins to filter out to the church, and that's a kind of wonderful thing to have that to have that happen for us. I'm going to start with an interesting question with that in line, and I'm going to go out of order on questions here. And I haven't scanned here to see if Thomas Rogers is in our audience.
No, I don't think so. No, so we can move on.
Okay,
I am
so
here
maybe,
actually.
Oh, yes,
I'm here.
where?
Oh.
I don't.
And
You got a different name.
Off the video, Bon and Tom. Yeah, right. my wife's-
No wonder I didn't see it. Didn't recognize it.
Right.
Yeah.
very good, Tom. Thank you so much for your question, and it's an interesting and helps to set the context. And so I think maybe just to briefly, if you can just say the key piece here, I think, is your last sentence in your email, that follow up. If you want to, do you want to state that for us?
Okay, I don't have the question in front of me here.
Well, maybe I could do it.
Yeah, read
Tom,
it
maybe
back
I
if
could
you
do
don't
it
mind.
for you.
Sure.
So it was very well stated. I mean, you start by saying that since scientists have proven over and over through the last 70 years that we do not have enough intelligence to build even one living cell from elements, does this prove that superintelligence far beyond mankind's level is essential to the building of living cells from basic elements? And you say that since evolution, by definition, has no intelligence to use, so is it in truth disqualified both as an origin and cause of life? Does our creator, the God of our nation, deserve 100% of the credit for life? And I think that's a question that many in the ASA have asked at some stage in their journey and professional formation. So it's an excellent question. Steve, Randy, you want to take that?
Yeah, I'll take that one, because I think that last sentence is so critical. And Steve and I discussed your question. Thank you for submitting it in advance. That we felt it was important to lead with that and set the tone, because your question, does the creator deserve 100% credit for the origin of life? Absolutely.
Mhm.
But we want to make it broader, not just the origin of life, but for all of creation. And Steve and I want to emphasize that anything we say about mechanisms and how this might happen, none of that is exclusive to the notion of God as being the overall author and creator of all things. So what we'd like to say is that we don't understand all the details of how God created the earth and what all the implications are. So we have, that's part of the ASA's role. We've got, we respect different opinions and different ideas. And so we want to be open and free as fellow believers here of sharing, critiquing, and throwing different ideas of how things happen. So we're going to present some ideas that are more in the vein of what are possible future research directions. We do not, and I want to emphasize, because I did get one email, someone who misunderstood it, we are not claiming we've demonstrated the origin of life. We're not saying that we know how to do it or solve the problem, not by a long shot. But we are suggesting maybe some different terminology, different ways of thinking about things, and different ways in which the research could paths that research could pursue in the future. So in terms of intelligence, it's in terms of the intelligence that is needed is God's. He's the creator. He created it all. So yeah, that level of intelligence was needed. What he needed as components, I think, is what we can research. We have to look at that. You want to add anything, Steve?
I know, I think you've handled it beautifully, Randy. I think I'm maybe just add as a sort of curious little footnote for those of you who read the paper. Randy pointed out to me late in the evolution of the paper, we were doing that thing that scientists sometimes do when they publish in Perspectives, where towards the end we had a faith statement, right? And we moved it right up to the front to say, no, that's really important to us to say at the opening, yeah, we choose to believe that God is the creator. God's intelligence is behind the entire universe. And whatever else we're saying here about abiogenesis, we're just following the view and advancing the view that it sort of reintegrates into God's intelligence in the whole of creation as we find this unstoppable process leading to life within the universe in the view that we're espousing. But thank you for a wonderful question.
Okay. Can I add one comment?
Just briefly, yes.
Okay. Because our group has been working on this for well over 2 decades to develop a God-based life science. And we don't talk about Satan's role in this world very much, but I think we should pay more attention to his actions. And it's occurred to me, because of our public education system purposefully excluding God from any mention in the classrooms, with penalties and firings and so on. I feel that Satan may be picked up on evolution as a great way to separate students from God, and it's working.
Yeah, thank you for that, Tom. Just so you understand the ASA, we are an organization that does not, by our mission and principles or policy, we don't take individual positions on issues. Members and our partner organizations and other organizations certainly do, and are advocates for these ideas and various points. We try and be that platform for the conversations out there. So thank you. I'm going to mention that folks can direct themselves to Tom. Maybe you could do that in the chat. Is just put in the chat, if you could type in the link to your organization, and then if people want to follow up with you, they can contact you that way.
Okay, thank you.
Thanks. Yeah, thanks. Well, let's go to the next questions. And Luke Jansen, I saw Luke here somewhere, and Luke has pride of place in fact of getting the first question in. Dell, you were beaten out this month. Dell, for those of you who don't know, has a long record of getting the first question in each month. But this one has come in from Luke Jansen, and actually it's a sort of a multi-part question. But Luke, if you can give us the quick summary and get out, and we'll let Steve and Randy unpack your question.
Okay. You can hear me, I'll assume. And I apologize if the party next door, if you can hear that. First of all, Randy and Steve, great paper. Really enjoyed it fully. And I suspect the fourth one is going to be in the works.
That was the concluding paper.
Oh, was it? Okay.
We stated it.
Okay, so we're all familiar with the many arguments and counter arguments about how you can get this genetic information arising spontaneously, and I won't reiterate any of that. But we also need to think about the mechanism that decodes that information. And so using the example that you used in your paper about the Wordle, the secret word, the 5-letter word, will not be discovered by a 5-year-old child who's still very adept at spoken English, but can't read. And so my point being that the decoding mechanism that is needed to orchestrate something as complex as all this moving around of large chunks of DNA is itself an extremely complicated mechanism. And so this is, now I get to my actual question. Here, we have a philosophical dilemma. Either there was a sophisticated decoding mechanism already in place to translate the gradually increasing complexity of the genetic information, and so that again points to a intelligent design, or there had to be a concurrent evolution of both the code as well as the decoding mechanism, and that involves a highly improbable event multiplied by a highly improbable event, and so again, astronomically improbable. And what I'm getting at here, for those who don't know enough about genetics, would be the group of tRNA molecules. They are the ones that do the decoding. We all know about the DNA, and we may know about this thing called polymerase, possibly. But there's the decoding mechanism, which is the tRNA, and that is a very complex mechanism in itself. You have to carefully. Well, I'm going to let Steve or Randy explain what tRNA is. But the fact is, it itself is a very complicated mechanism. And the irony, the paradox, let me find it here, that it's complicated by the fact that the decoder, the tRNA, is itself encoded by the code that it's meant to decode. And so that's my question. What do we do about this decoding mechanism that needs to be complex right from the start, or can it work otherwise?
Okay, so Luke, let me just start by saying you submitted a little different question in the sense of you started by something different and then so you omitted the first part of it. Well, then
Okay,
I was eager to answer, but I can't answer it because you didn't ask it. Anyway,
okay, go ahead. How can, very quickly, Randy, how can we have complicated stretches of DNA arising spontaneously?
Well, okay. There are some other topics that you brought up that you didn't ask here that we can do a little differently. But Steve, why don't you go ahead and answer what he did ask about the genetic code, and maybe we can come back to the other topics.
That's so kind.
Later. Okay.
Yeah, Luke, it's lovely to see you. Thank you for all the work you do on this faith frontier. And Randy's strict instruction on this one is to shut me up because, as you know, this is where I come from, right? My origins as a scientist with the
go for it, Steve. Go for it.
So yeah, I try and think. Look, the bottom line is you're asking a really good question. I think. Sorry, the last little bit of preface is that there is a vast literature on the evolution of the genetic code. We don't know the answer, and the question is how far and which bits of that are worth bringing into this argument now. From a secular point of view, secular science, the evolution of the genetic code is pretty universally now regarded as something that came later than the origin of life, whereas once upon a time it was seen as synonymous with the origin of life. Now, there are a whole discussion we could have there that would be hours, but the RNA world, the idea of a simpler world before the genetic code came along. What I can say is that the secular world believes that the evolution of the genetic code was secondary to the origin of life. It came after. How did it happen? We don't know. There's a vast literature. I would argue that one of the big themes running through that literature is that what we see today is a sort of rarefied outcome of a lot of evolution, and that the origins of it probably lay in biophysical interactions between molecules, literal connections. So the heart of the question you're asking, there are two chemical languages that define life as we know it, proteins and nucleic acid. And they're different. They're different languages. For those of you who know fundamental computer science, it's very much like a binary code and an ASCII character set. They're different. And the code is what links them, just like the ASCII character set. And this is what Luke's talking about. So the main theme running through this literature is that it began with some sort of biophysical interaction, which through evolution became ever more abstract until what we see today with the adapter molecule, the tRNA that Luke talks about. I could go on, but I really don't want to. I want to be clear that we don't know. That's where the thinking is. I've got a couple of papers on my desk right now that I've got to review for the latest round of input on this. Mike Yaris, I'll put that in chat, would be a name if you want to sort of really get into the weeds with this. He's one who has really pursued this idea of biophysical interactions, which gradually became rarefied and abstracted into the adapter molecule as we see it today. So that's a very mechanistic answer, but I think Randy is going to go a bit deeper than that. If you look at, what lies behind it. Randy, over to you.
Well, it depends on how much of your unasked question I can answer. But let me give it a whirl a little bit, because I think it will circle back and help a little bit. In the first part of your question that you submitted, you made used a couple of phrases that I think should be spelled out and commented on before we continue with the rest. First of all, you referred to specified complexity, and our paper is indeed filled with a focus on complexity. But I just wanted to point out at the beginning that it, of course, is widely discussed in terms of the origin of complex specified information. And many people are asking the question, where did that information come from, as a central part of both the origin of life and evolutionary development. And what I wanted to point out before we get into the rest of the paper is that in this paper, we're offering a perspective that says a continuous cycle of complexification and simplification are a beautiful example of how complex specified information is created. The complexification part of the cycle increases complex information, but it's not necessarily specified. It is to some degree, partially because of its background, but the simplification process further provides the specificity. And so you get this continuous cycling between the complexification and simplification phases. Complexification, of course, is basically reproduction with variation, and the simplification is nothing other really than the selection process, so the selective eliminations, if you will, so that it really injects information into the system. So you've got both cycles injecting information into the system. And that's a very powerful way of increasing complex specified information. So I just wanted to level set you so that that's a key way of thinking about our paper and how it contributes to the development of information. Now, the other phrase that you used, Luke, that I thought needed a little bit of discussion was the phrase astronomical improbability. You kind of said, it's a little tough to roll off the tongue, but you kind of use that and says, okay, we all know that there's astronomical improbability in all this. Yes, there is.
Randy, if I could just clarify, especially for the listeners, what I'm saying is that's the common young Earth creationist argument against a lot of evolutionary arguments. They'll say, well, that's a statistically, astronomically improbable event. That's where I mentioned that. I don't think.
Good point. Yeah, good point. Okay. But that issue arises all the time. And I wanted to address that up front because I think it's worth thinking a bit about how does the astronomical improbability arise? And if we were put abiogenesis aside a little bit, just focus from an evolution point of view, let's suppose we take a hypothetical ancestral population of mammals, perhaps, and ask, okay, what does it take for this population to evolve into Homo sapiens? And we look at Homo sapiens, we look at what it takes to do that. It doesn't take much to do the calculation to find that, wow, it is astronomically improbable. What are we going to do with that? Well, in order to understand that, in all probability arguments, we have to use analogies of throwing dice or dealing cards or something. So let's talk about dealing cards. We all know card games. You deal a set of cards, and when you pick up your hand that's been dealt, and you look at this, you can easily do the calculation. The probability of you getting that hand was astronomically improbable. That's an easy calculation to make. And so what do? You say, this didn't happen, let's redeal? No. You go on playing. So what do we do with that astronomical improbability? We just ignore it there. But where did it come from? Why is it there in the first place? And the reason it's there is because you're taking an existing endpoint, the hand, you're retroactively applying it to the dealer from the beginning, and you're kind of saying, all right, what are the chances at the outset of this dealing process? What are the chances you're getting this particular hand? That's where you get astronomical improbability. On the other hand, you have a 100% probability that the dealer will end up with a hand. That he will, because he puts down, unless he breaks his hand, he's going to put down 52 cards and you're going to have a hand. No matter what, any hand he puts down is going to have an astronomical improbability. So it is 100% probable that it'll happen. All right, so what was happening there? We are imposing a goal that the endpoint was a target and intent of the dealer. Now, if that were true, he'd be cheating, and that was tough. But this is my point, that astronomical improbability arises when we retroactively extrapolate a goal and a purpose back in time. And I would suggest that by analogy, if you think about the evolutionary development, that the same thing is happening. The reason we can end up by saying we have astronomical improbability of our being the result of evolution is because we're taking Homo sapiens as an intended target. We're taking that back to some ancestral population, pick whichever one you want, and we say, all right, what does it take for you to have a series of mutations that will end up with Homo sapiens? Odds are astronomically improbable. I mean, it's easy to calculate. But where did that arise from? Every process along the way was probable. Every generation along that way has a high probability, almost 100%, not quite, of producing another generation as an offspring, which itself is viable. And so if you continue that, you really realize there's a very high probability that at the end you will have a living species. What you don't know is whether you'll have Homo sapiens. And so the improbability comes up as we extrapolate and impose a goal or purpose of Homo sapiens back to the ancestral population. Well, what does that all mean? Well, what that basically means to me, at least, and I would suggest for your consideration, is that talk of astronomical improbabilities is not a scientific problem. It's not a scientific dilemma. It's a philosophical and theological dilemma. And it comes about because we think that we humans were intended. Somebody wanted us to exist and manipulated things in order to happen. Then you get into a lot of probability kind of issues.
Right.
But it's not a scientific issue, and I would suggest that we need more theologians to look at that. And I know one who is here in the program, Chris Berriger, who has looked at this, and I'm not saying he's right or wrong, but I think he's addressing the right problem. And maybe, Chris, you can put a link in the chat to your paper, so people to see what I'm talking about. But I think that's an important piece to recognize, that when we talk about astronomical improbabilities, we're talking philosophical and theological issues. The inverse of that means that from a scientific point of view, we don't see that. And we don't see processes or expect processes to occur that have a very high degree of improbability. And what Steve and I are suggesting in this paper is that carries over from the evolutionary development over into the abiogenesis phase. That we think that we're not sitting around and waiting for some life thing to pop out of the prebiotic soup. We're not looking for that kind of a miraculous event. We're looking for highly probable events that occur in whatever fashion, simply kind of a fashion, of which life emerges over time. So, yeah, your use of that phrase, Luke, helped me to trigger this kind of perspective of how to position our paper.
Right. So, John, I'll just be one more minute. So, Randy, the reason I didn't ask that was my preamble. I wasn't questioning the evolution of the code, but rather the evolution of the decoder. And again, to use your example of the Wordle, right. I wasn't asking about the evolution of the English language, but rather the evolution of that 5-year-old kid who can speak English but can't read it.
Fair enough.
And so, Steve, if I got your answer correctly, I said there was two possible outcomes, one of which was there was a sophisticated decoding mechanism in place. I think your answer is yes, but that decoding mechanism was in place because it had already evolved through a different form of life before there was anything about DNA on the table.
Yeah, I mean, honestly, if I can let me try and be more responsive to your real question here, because it's such a good one. I believe that if you look at the younger generation of more interdisciplinarily trained scientists, they increasingly strongly regard every feature of the central dogma, as we know it, DNA, RNA, proteins, as being an evolved outcome, not where it began. That's a huge shift over an older generation whose excitement at discovering the central dogma made them conflate that with where it all began. So this emerging generation is saying all of that was refined by natural selection. So I worry that I'm doing this on the fly, and it may be careful, but in terms of your metaphor, it's as if the child with spoken language was there chemically in something less sophisticated, less interesting than written language, and writing evolved later, the way that a child's development might get them to writing later on, right?
Okay.
I've got to think through if that metaphor really works, but does that resonate for what you're asking here?
Yeah, yeah.
Thank you. Yeah. Now, a lot of excitement is where on earth do we look for that messy chemistry, these forerunners? But that's where I'm seeing some of the most interesting, exciting, and innovative work from the youngsters. Yeah.
Thank you.
Very good. Thank you, gentlemen. I'm really resonating with this conversation because I think it's opening up what some of the follow-on kinds of questions and issues. Steve and Luke, for this last few minutes, contextualizing that in where the science has gone and where it is today is really important in this conversation. It's stunning to me, having been in grad school in the 1970s, to see where we are today. I started in graduate school and we did not have a way to do the simple kinds of things like restriction enzyme had just happened in 73. The sequencing comes much later. I'm already almost out of graduate school and it's happened. You just see the speed of the rate of research and the numbers of individuals. It's no longer concentrated in North America and Europe even. This is literally around the world globally, and it's awfully hard to keep up. So this has been very helpful. So I want to move next to a very interesting question, actually a series of questions, but I'm going to ask Marty Pomeroy to just ask his first two questions, if you would, that came in, and I think they follow up quite nicely on the particulars here. So, Marty, if you could unmute and go at those first two questions.
Okay.
Please do.
One observation that I have is that this, and I think, Randy, you mentioned this is a very philosophical discussion. And my concern is that in the context of a philosophical discussion, people cite only the evidence in favor of their perspective, in this case, continuity, in order to argue on behalf of continuity. And I think that that's begging the question. Continuity is an article, I believe that continuity is an article of faith underlying the series, and I'm not sure that the arguments are taking me there. And then the second point was interesting development. I liked your development of complexification and simplification as, other terms for mutation and natural selection and its application to abiogenesis. But then you only focus on simplification as if natural selection is a driver. But it's not, it's a filter. The real question again, and I think this was reflected in some earlier discussion, whether enough organized complexity sort of arises in the environment on its own from which it can be selected. Mm-hmm. Mm-hmm. And that's the issue, and that's the struggle. Yeah. I'm not convinced that it does. May I throw in my very last paragraph?
Well, can we address these?
Randy, let's start with these two questions.
Okay, thank you.
And focus. It's very good, Marty. It's really helpful. Go ahead, Randy.
Well, I think for your first one, and you say we focused only on arguments, data in favor of continuity in order to argue for continuity. I think it's well, we're not trying to argue for continuities. We're trying to say this is a path of research that we'd like to see more, and which is why we only focused on continuity. We want to say, hey, we think it's worthy of it. We didn't view it as being a basis for arguing this is why continuity is correct, but rather we're saying, yeah, there's been a lot of research in different ways, and we think the continuity aspect is worthy of further research, and that's why we do it. So I don't think it's begging the question very much, because it wasn't our intent to use that as proof of continuity. I don't know. I don't think I said that very well. Did I, Steve?
I think you said it better than me when we were talking this through before, but it is just that idea that I think we were arguing for something that is plausible and unrecognized. And that was why we were favoring evidence to show this thing that we would like to put under the spotlight, rather than trying to compare it against what we consider to be a dominant alternative. But Marty, your point is well taken, and we wouldn't want to be construed as having thought that we'd formed a logical argument with a fair comparison that favored one particular version.
Yeah. And I think there's a similar kind of comment on your second part on why we devoted more time for simplification than complexification, and that is that complexification is more familiar and has been focused on more, whereas simplification, hey, when I first heard that from Steve, I didn't buy it. I struggled with it. It took Steve a while to convince me of it. I didn't understand it, and wasn't sure I agreed with it. But I finally saw what he was getting at, and I thought, wow, this is interesting. This is a novel way of looking at it. So yeah, I mean, we plead guilty to spending more time on simplification than complexification, simply because we thought it was less understood, and the role of it wasn't quite there. So we didn't mean to favor one over the other, just to spend more time on it. Now, you said the key question is whether there's enough complexity. Well, I don't know, but I don't. We don't know if there's enough. I don't know how you could ever show that there was or there wasn't. It's not something you can directly prove. Is there enough? What we do know is that the complexification exists. We know the simplification exists. These are processes that we observe, and we see the end results. And there's an awful lot of middle ground of hundreds of trillions of different species in different conditions. I don't know how we could ever show. Yes, I know. You and I've had many, many discussions, Marty, over the time, and you're convinced that it's not enough, and I think it could be. I've never been able to provide enough evidence for you, and I probably can't. And I don't have it. I agree, but I also indicate that you don't have the evidence to show that it isn't. And so I think further research is needed.
All right, Marty, thank you for those two questions. I'm sorely tempted to jump to your next ones, but to be fair to other people, I'm going to come back to you though. So, and let everybody know that we're cycling through here quickly.
Thanks.
And Sigard has a question that has come in. Cy, can you unmute and ask that question?
Thank you, John. And let me start by saying to both Randy and Steve that I think you made a tremendous contribution with this paper in several areas. One, of course, is the wonderful definitions of complexity, meaning, and information, of course, which has been lacking in the literature and caused a lot of confusion. So I thought that part was really very valuable and something that people will refer to for quite a while. I also very much like, as you know, Steve, you've convinced me about simplification, and I very much like the cycling idea of going back and forth between the two. It really has a good ring to it. But what my question was, and Steve, you pretty much, I think, answered it to Luke's question. At least I think you've tried to answer it. and that question was, you talk about the machinery of the translation, and in there somewhere it says that the machinery can run by itself. It doesn't need a conscious. Well, of course, that's true for all machines. That's true for a computer. There's no little guy in the computer, trying to add numbers together. So the question really is, where did that machinery come from? And it's even more complex than has been discussed. I'm not going to go into great detail, obviously, but as you know, there are these sets of enzymes, the aminoacyl tRNA synthetases, which actually put the correct tRNA together with the right amino acid and make sure it got the right one with an editing site. So this is a level of sophistication that's beyond anything we can make, even in the real world. So the question is, where did the machinery come from? And if I understand your answer to Luke, who asked a similar question, it has to, you're saying that it evolved.
Mm.
But the problem that I have, and I've discussed this with both you guys in the past, so it won't be new to you. The problem is evolution requires more than natural selection and variation. It also requires accurate inheritance. And that accurate inheritance is conferred by this very system, which we're talking about. So the question is now, how is that possible? How can we get an evolutionary, in other words, I think the answer might be, and you might agree, that it's another kind of evolution that we're not aware of, that somehow is able to overcome the requirement for a very highly accurate replication system, which we now have. And that probably evolved from a primitive form, but it had to start with some degree of accuracy conveyed by this translation system. So my question is, would you agree, and I guess I'm mostly addressing Steve as the biologist here, sorry, Randy, but would you agree that we may be missing something in evolutionary theory related to this? There may be some biological or chemical or biochemical laws or forces or whatever that we're not aware of that might be able to confer such an evolutionary pathway before we have the current pathway that we now are familiar with.
Thank you, Sai. Great question. Thank you for your kind words. And I must admit, I didn't know that we were as aligned as we are now. Thank you. That's really, I thought we were still very much seeing it differently. But onto your question, yes, in a word, yes. Yes, I think it's one of the things that interests me most in the abiogenesis community. Again, forgive me, I keep thinking about the youngsters, but I don't count myself as a youngster. The youngsters asking to see a bigger picture and asking to see natural selection as we understand that term, biological evolution as we understand that term, to see that as the center of a Venn diagram where we don't know what the outer rings are. Chemical evolution, compositional inheritance, ideas of evolution that are beyond what we come to think of it, because we understand all of it in terms of DNA and proteins. Now let's just take it in two levels, and I'll be as brief as I can, and I hope I don't lose those of you who don't know or care about this stuff so much. But the traditional mainstream view, the RNA world hypothesis, would argue that you don't need a genetic code to be in place to get a very sophisticated evolving organism, because it's just RNA. And that the genetic code and protein encoding evolved against the background of a sophisticated RNA genome. So that sort of gives you a little bit of an out on this, because you could start to have sloppy genetic coding if in any way it augmented or improved the RNA world. And that is the mainstream view.
Right.
I would argue, for reasons we won't go into today, I don't even like that one. I'm much more interested in this other stuff that they're looking at, where we're looking to see examples of things that inherit with fidelity that don't involve linear polymerized sequences. Now, a broad term for this is compositional inheritance. And the best critique of it is we don't have any clear evidence of it working. We just have a lot of really tantalizing hints. I think it's also fair to say we haven't tried very hard, because as John put forward so beautifully to us, I mean, he was in grad school. I was in grad school. We were still very much in a central dogma world. We were excited to have found the molecular basis of life. And a scant 40 years later, we're like, what else could do this? So some of the most interesting work I see is looking at how lipids could do this, where they're not covalently bound to each other. They're just, but there is a compositional inheritance that they can carry over from one to another. We are so far away from scientific evidence of this working, but it's the direction I want to look in, because your question is such a good one. And I think just to sort of round this out, and I'm afraid it's back to hand waving and philosophy, it is this idea that the exquisite architecture that we see today is a product of natural selection. And therefore there were probably many steps before it from which it evolved. Somewhere in there is a paradigm shift of life creating itself. And in this audience, I hope that doesn't sound like we're trying to push God out of the equation. I still see God as the architect of the universe, God throughout this entire process, but that there is a remarkable way in which the material basis of this universe cascades itself into what we come to see as the natural selection algorithm, and evolution proceeds from there. I find that wondrous. I find that inspiring. And I'm hoping that that's the science we're going to see over the next 25 years. I could be utterly wrong about that. And we'll get back to Marty's point. We're not so much arguing this is the case as saying we want you to be aware that this is something interesting that is kicking up as a question. Where else can we find natural selection? What else evolves? What are the limits on that? Where could this begin? It's a very careless analogy and probably a bad way for me to finish, but it keeps flipping through my mind with these recent questions. And I'm going to butcher it, but that apocryphal interaction with Michelangelo asking how you sculpt these beautiful sculptures from a block of marble, and him replying, the trick is to remove all the bits that aren't an angel, right? That's what natural selection is doing with matter, is removing all of the stuff that isn't life. That's the simplification that we're so interested by. Let me stop there because I've probably given an overload, but Cy, what does that do for you?
Yeah, no, I think that's great. And I've been very, in respect to what you said, I've been very interested in something that was new to me called cognitive evolution. I don't know if you've heard about that, but is that something that might fit into what you're talking about?
I don't think I know enough about it. We should talk about that, shouldn't we?
Why
don't you tell us something?
Yeah, we'll be in touch. Okay.
Thank you. But would you like to say anything for this audience about what you're seeing there?
Well, I'll tell you the truth. I don't have a handle on it yet. I've just come across this. I've been very interested in the issue of teleology and agency in evolution. And apparently a lot of people, most of them non-theists, by the way, share that interest. And I suddenly started seeing papers coming along from 2021 and 2022 with all about this thing called cognitive evolution, which has the idea that, there are microorganisms, there are very primitive cells that have some form of cognition. This is now well accepted. But the question is, does that have anything to do with evolutionary mechanisms? And I think it's obviously an open question, but it's intriguing. And it might relate in some way to what you're talking about, is other modes of natural selection, which is fascinating. I think
I'd love to talk with you about that. Thank you.
Yeah, we will.
Cy and Steve, I'm going to jump in here at that point because that's absolutely fascinating. It's a side trail to our focus today, but a wonderful one. Cy, you guys make sure you come back to that. It's a fruitful area for conversation. But let's go on with another question. And this, Steve, plays off of your comments about the RNA world. And Del Kuhn has asked this question. Del, as I mentioned earlier, came in second this week to Luke, but he had a very interesting question about the empirical data understanding the RNA world. Del?
Yes, thanks. Yes, thanks, John and Randy and Steve. Thanks for your articles. I enjoyed rereading them for this month, and my reaction to them again is, why not? It's an interesting way of looking at them. Life as information. What I'm trying to get a handle on is how much or how do we measure the information or maybe meaning content of something. I'm using RNA world because I think it's the standard model. And also you've got the possibility of a ribozyme or an entire genome of about 35 or 3,800 units, or ribozymes of a couple hundred units, or even active sites of a couple dozen units. What kind of a handle should we be looking for information as maybe the way to interpret the experiments that are going on?
Steve, that one's yours.
Oh, thanks, Randy. Thank you ever so much, Del. I'm looking to see if I can copy an email that I wrote to John when we first saw your question and he asked for a response, just because there were a couple of hyperlinks in there. It's a wonderful question, Del. Thank you for that. I need to be full confession. I'm not an advocate of the RNA world. And I think even 10 years ago, that would have made me an apostate in secular world. These days, it seems that there is a turn against what we used to think of as the RNA world. But I just want to get that out there. But let's follow through your question as a thought experiment, even with the RNA world. So you're saying, what is the minimum amount of information we need? And I think you mean, but please correct me if I'm misinterpreting, for a self-replicating molecule. Is that right?
Correct. Either for self-replicating or something that can interact with its environment to make another one of itself.
Good.
an instruction set that gives you whatever it gives.
Yeah. I mean, just to show how on point you are, that it is absolutely sort of a paradigmatic question that has guided most in the field from about 1960s until about now, but it's waning now. Everyone else thought that that was the right question. So I can speak to that, and I will paste in here in a moment. Sorry, getting distracted by chat. I'll paste in here in a minute some links to the literature on that. But I just want to make quite clear that in part one, what we were arguing that's a little bit more controversial or less widely accepted is that that doesn't exist. That isn't the molecule we should be looking for. We're unusual in saying that. Since the 1960s, so many in abiogenesis have said that is exactly the question. What is the simplest molecule that can self-replicate? Our argument in part one is endless shades of gray back from that into something that sort of self-replicates, from which a self-replicating molecule evolved. That's what we mean by continuity. So I want you to know that most people would agree with you that you're asking the right question. You're talking to the two guys who are going to say, we don't think that's the question we can answer because we don't think that's how it happened. Okay? Now, just to be fair to you, let me try and paste in if I have it. Oh, no, I didn't have it copied. I'll hand over to you to make more comments in a moment, but I just want to say I'm going to give you some literature to the majority who do believe you're asking the right question. I'm going to put that in chat now. Okay. Back over to you, though.
You got it, Del?
Yeah, I think you're answering my question. I think I'm going to look forward to the links. I'm sitting here listening. I almost don't feel like interrupting the flow of the conversation by asking anything.
Well, you're extremely kind.
Well, then let me turn this a little bit with some trepidation, but I think David Singer has a question that I think fits in here fairly well, and really asking. You've presented a very thorough and naturalistic process for abiogenesis. But regardless of where one starts, shouldn't we be able to see the process or evidence of the process in actions today? That was the question you asked. And David, I want to editorialize on that and contextualize it, Steve, I got to thinking about a very similar kind of thing in the other direction. And I was thinking, these scaffolding mechanisms, these early steps that we're talking about, whether it's RNA or pre-RNA or wherever it is, should we see, as David's asked, shouldn't we be seeing evidence of those things around? Or are they so sort of ephemeral that they were necessary in the process, but you don't see them at the end because they're either not useful or they're outcompeted or they were for a time? It's like saying we don't see dinosaurs around today, but you really kind of need a Tyrannosaurus Rex to get to birds. And you don't get the birds if you don't get a Tyrannosaurus Rex, well, that's maybe the wrong one. Some paleontologist is going to jump on me here, but you know what I'm saying. The analogy here is that should we be seeing these things still extant and active, or what?
Randy, do you want to take a turn, or are you going to?
I was about to pass it off to you, Steve.
I'll do it, but I feel like I've been talking too much, so you give it a crack.
Well, no, you sure haven't been. I'll pass it to you very quickly, but I do want to say that, John, you've got a point here that, Dave, you say, shouldn't we be seeing it now? And I think, in a sense, we are seeing it. We don't recognize it because we don't really know what to look for. And I think we're so attuned to thinking that life is what we see now, and that this is the definition that we're looking for. And so we want to emulate. And so we do all sorts of exercises to say, well, how simple can we make what we see today? And that simplification model, a lot of people say, what's the simplest cell we can construct? Well, okay, so you can take off all sorts of things and say, okay, here's the simplest cell we can make. But that's just the simplest cell that can imitate what we see today. That's not necessarily on the path to developing the cell. So the concern is, are we going to recognize it? And that's more difficult, which is why we emphasize in the paper a little bit more the high-level principles, because it may well be, and probably quite likely, that the information necessary to reconstruct both the environment and the actual systems that were the forerunners of everything else, the information to decide that may be gone forever. We may never be able to ascertain what they were. However, what we can do, and that's what we're suggesting in the paper, is look at the plausibility of the physics and thermodynamics and the chemistry, especially systems chemistry. We wanted to point that out in this article, that maybe you caught it in there, just a few references there that's saying that so much emphasis has been put on synthetic chemistry for the origin of life, which appears to be not working out, especially if you've heard Jim Tour claim. And yeah, synthetic chemistry isn't panning out very well, but systems chemistry is coming up as a way of looking for really dynamic systems with dynamic kinetic stability, where you have groups of molecules, not necessarily a molecule that will replicate, but a system that will replicate itself and get some rudimentary forms of systems that have some stability. I'm more interested in going even further back, and that's why I included Jeremy England in this article, because he looks at what comes way before that, before you get into the organic molecules. What are systems, what happens energetically, and you can see that as you inject energy and cyclical energy waves into a system, that you really sustain systems in high-level states, in metastable states or above. You can populate that, and you get all sorts of different chemistry and different behavior than you do if you just look at stable situations like the synthetic chemists like to do. So it's a wide open field. There's a lot to look at, and I just hope we recognize it when we see it. Steve, your turn.
Nicely said. Yeah. I mean, I guess it just reiterates maybe in other words, and if these, anyway, what do I think? Great question. Probably, for my taste, the most troubling thing for those of us who are interested in life's emergence from a non-living universe as a probable event. And I mean the secular folk. This is the question that plagues us, right? But the three answers, and I think Randy's kind of given them. Firstly, yes, things were very different back then, 4 billion years ago on the Hadean on Earth. Conditions were very different. So that's a little bit of a hand wave. Maybe something there was important to get it going through a stage from which we now emerge. But we shouldn't expect to see Hadean-like events now. Maybe. I don't know if I buy that. I don't know how convincing that is. Number two, Darwin's point. Anything that did get going a bit like life biochemically as we know it today would look straight up like food to life. And there's an awful lot of life here, meaning that the presence of life on Earth is now quite a big block to proto-life stages on Earth. Bits of RNA, bits of polymer, bits of anything like that, that's straight up food for all the microbiome that's out there. And, Darwin was among the first pointed out. So maybe the conditions are different. Maybe the halfway steps towards life really are blocked by life now, because life would consume them, outcompete them, and literally use anything that was on the way to it. But I think, both of those two, just hand waving, maybe that helps, maybe it doesn't. I think the one that interests me is answering in a slightly different way. I think we do see it. If you choose our lens, the lens of people like us who see life as something that almost inescapably flows out of non-equilibrium physics, you see proto-life stages that aren't biochemically like life, because those ones are busy getting eaten by life, right? But you see self-organization all over the universe, and we're just beginning to become aware of that. Matter that organizes itself, that starts itself on interesting journeys. As far as we can tell, most of those alternatives don't go as far or as interesting as life as we would comfortably recognize it. But I could point you to one or two folk out there who point how weather systems moving particles in atmospheres do self-organize into vortices over and over again. And they say that's a bit like sort of things self-organizing towards a lifelike state. It's just that that system doesn't seem to have the potential to keep going in ad infinitum the way that one system did back in the Hadean and led to us. You know, I want to stop rambling and just say that is the question. We need to answer it. Yeah. Maybe things were different. Maybe life itself blocks proto-life today. And maybe we do see bits of journeys of self-organization all around us if we choose that lens.
That was very, very helpful question. It's opening up another very interesting area, Steve. Just when you point to the rest of the universe as we look out away from the Earth, all of the exobiology study that has happened and all of the data that is just flooding in, reminded of Deborah Haarsma's talk at the ASA meeting in 2019, just pre-COVID, and she talked about exobiology and what we might know, and identifying what might be happening in other places. That's going to the extent that we can reach out that far and get information in and understand how that might work is going to change our ideas. We're already doing that with Mars. And, that's what the Mars rover projects are all about, to try and understand. It's absolutely fascinating. So, David, thank you for that. I'm going to turn now to the questions that are showing up in raised hands. And Joseph, you're the first in the queue here. So would you unmute?
Thank you. If there were time, I would love to discuss the thermodynamics of the organic chemistry reactions in your paper. Amino acids turning themselves into peptides, mononucleotides turning into oligonucleotides. Those are definitely inorganic reactions. They don't happen that way in the biosphere. They go the other direction. Nucleases and proteases break down peptides and oligonucleotides into monomers. But you postulate wet-dry cycles, for example, and it is true. If you put an amino acid into the oven, it'll turn into peptides. But you put it into an aqueous environment, won't it go back the other way? Whatever catalyzes the assembly in your dry state is going to catalyze the breakdown in the wet state. But anyway, I wanted to put a quote by Alexander Oparin into the mix here. It's something he wrote in the 50s, I think. He was laying down the ground rules for researching abiogenesis, and he wrote, we have to insist that the origin of life did not involve some kind of super intelligent being who entered the world, was crucial to life, and then left. And to that I say, amen. He hasn't left. Thank you.
Is there a question there, I think?
Well, the original question was, won't the wet cycle undo whatever progress was done by the dry cycle?
Well, Joe, first of all, I want to underscore that please don't attribute to Steve and me that we're advocating or proposing wet-dry cycles. If you recall, the positioning within the paper is we are trying to give some examples of researchers who are pursuing a direction. And that's one of the ideas being pursued. We're not trying to say that, hey, we think that's the right way. We think it isn't. However, it is an example of a way to proceed in research. And to me, it illustrated the potential for cyclical systems. There's a lot there of doing it. So yes, I'm sure you're right. I mean, I don't doubt that. I think it's right. There are systems that won't withstand cycling, and but there are also systems that thrive on it. So I just wanted to clarify that.
Yeah, well said. And I think Terry said it does depend on concentrations. As Randy says, it's not us. It's actually a lot of literature going back decades. Some of the most interesting current stuff I'd see, if you look at Jay Forsyth, he's interested in heteropolymer mixtures of hydroxy acids and amino acids that self-purify into amino acids under wet-dry cycling. So it really, we do have to be careful about statements of fact here that, yes, no, this stuff, there's decades of research that says under the right conditions, this stuff does form polymers under wet-dry cycling. But Joe, the biggest thing is just where you ended. I think I can't state clearly enough how much Randy and I agree with you. Yeah, God didn't leave. God has been throughout, since before the origin of life, through the origin of life, throughout evolution, and through today, and will be with us tomorrow. God hasn't left. Thank you for that, Joe.
Very good, Joe. Peter, you're the next up in our raised hands, so unmute.
Yes, thank you. Well, someone mentioned exobiology. I think this is very important because it may be that the probability of life developing by any of these mechanisms is indeed astronomically small. But on the other hand, there are billions and billions and billions of planets in the universe, and it would be sufficient just for one of them to work, as it were. On the other hand, if the calculation said it was extremely small, but we found life on Mars, that would really, as it were, set the cat among the pigeons. So I would urge you, if you possibly can, to try and get some numerical probabilities put into the kind of mechanisms that you're proposing so that this sort of thing can be considered.
Thank you, Peter. Do you mind, Randy, if I have a very quick response to that? I hope it's quick.
I was just going to defer to you.
Oh,
Go ahead, Steve.
Okay, well, you follow this up. Peter, I couldn't agree with you more. I want to firstly harken back to a connection that Randy was making and is in chat to Chris Barringer, thinking about this exact argument for the presence of a self-reflective creature that can know God. And this, I just think what he's writing gets right to your point, and you'd really enjoy his book if you haven't had a chance to look at it. His paper in ASA. Yeah, thank you. For what it's worth, you're talking to two people here who would argue that probability is close to 1. Now, we almost do that again in the spirit of saying, because we're trying to get away from an older assumption that probability was close to 0. I actually do believe the close to 1 argument, and that would almost be a whole other hour to talk about why. But I think you're right on point with saying that number, narrowing its boundaries, is an incredibly important step for near future science, and that exobiology is the way to get at that. I mean, there's a stunning lack of scientific exploration for the presence of life outside of Earth. People's minds often jump to little green men and Martian cities. We're not talking about that. We're talking about actual experiments. We've got 2, haven't we? Viking from the 1970s on Mars. That's it for our species. We are now launching multiple missions throughout the solar system, and NASA has increasing confidence of saying it is interested in looking for life. Be interesting, very interesting, to see what we find on our own solar system doorstep. And your point is very well taken indeed. I just applaud it, Peter. Thank you. Randy, what would you add?
Well, I don't think I'm going to add anything to this particular point. I've got some other things I'll add later.
Okay.
Thank you.
All right. Thank you, gentlemen. Peter, thanks for that good question. You got us moving. And so, Marty, I promised you that I would come back to you. And at the toward the end, you had 2 more questions there. Do you want to?
Well, I think my third question is just about the actual science, and I think that's been somewhat discussed. There's some real limitations right now on sort of possibilities. And I'll skip the next one. I would love to just wrestle with the last thing that I put there. You guys had a closing sentence. Is this all right, John? Can I go this way?
Yes, please do.
Okay. You had a closing sentence. We suggest that readers of this journal recognize that the mainstream scientific community studying the origin of life pursues naturalistic abiogenesis, not primarily because of a bias against supernatural intervention, but because of its potential plausibility. And my take is a little bit different. What I would say is that scientists pursue naturalist abiogenesis because it's the only thing they can do within their discipline. Various biases are present, but plausibility is typically not a question that is asked by those in the discipline. It is asked by mathematicians and engineers who know that meaningful order, or perhaps the organized complexity is the term you guys used, too rarely arises from chaos. And then I would just say, for simplification, the pair of them together, you're talking about these stair steps, and the issue is that there's not enough time for the number of stair steps. So anyway, comment on that. Feel free.
Sure. Let me start, and then Steve can fill in the gaps a little bit. First of all, your version of that last sentence starts with, that's the only thing scientists can do. Well, I would agree with that, because it is not a scientific possibility to study divine intervention. We don't know the causes and that. So yeah, there is a sense in which you're doing that, but I don't understand what you mean about the plausibility. I mean, plausibility is definitely, when it was at the Origin Research Conference, that's what everybody's talking about. Hey, we can push plausibility. So I'm not sure I go along with your premise of the other statement. So and in terms of only engineers asking that question, I guess I didn't really comprehend what you're getting at. Perhaps engineers are more likely to look at structures and things. Okay, how can we get this particular structure? And Steve and I are kind of saying, well, wait a minute, we don't know what structures to look for. They may be very different, and we need to look for different structures that have different properties rather than have the exact organic molecules that we'll have. Let's look for systems that have the properties that are necessary. Like Sai was saying, the key part is the accurate reproduction. And yes, that's exactly right. But what entails that reproduction? What is it that causes that? And we're looking at systems that have a different kind of replication or different ways of doing that. So we're just, like Steve said, central dogma is the only thing we knew about replication, and other systems can have different mechanisms. So I think there's a lot to be explored. And your final statement here in saying the too many steps for the time, well, that's your opinion. I differ a little bit. We're still friends, but it's I don't know how we could ever count the number of steps that are possible. Steve, help me out here.
Oh, thank you. And thank you, Marty. And again, I think, Randy, you very rightly pointed to two elements. I want to point to the first few elements, Marty. I completely agree with you, as does Randy. This is what scientists do. So that's why they do it, right? I get that. I want to take this in a slightly different direction and link it back to the point that Tom was making very early in this session about the way that Satan distracts people from knowledge of God or awareness of God, and suggest, as we reach towards the end of this time together, one of the interesting ripples of seeing life emerging spontaneously and easily through secular science from the universe is how much more it seems to be opening up some of my secular colleagues to ask ever more philosophical and I would say theological questions about the universe. What do I mean? That I'm in a workshop with 30, 50 scientists who are looking at this sort of way of seeing things, and they're asking, what is this property of the universe that we as scientists have so struggled to encounter before now, that gives it direction, agency, that leads to the fascinating outcome that is us here now being able to discuss all this and understand ourselves? I'm seeing that as ever more on the table in a way that really excites and interests me. I'm not saying that this science is right. If there's one thing I've learned as a scientist already, it's that 50 years from now, everything we think now is wrong, right? But that something about this leg of the journey that we're on is getting a lot of my secular colleagues to be more open rather than less open to asking questions, at least God-adjacent questions. And I'm seeing more talk about agency and more talk about directionality and purpose than I ever saw when I was a grad student 25 years ago, for whatever that's worth.
Well, that's good. It sounds like they're wrestling with the plausibility of just sort of random, I haven't got a better word, but producing so much complexity without some help somehow.
I mean, they're seeing it written into the fabric of the universe, and to them, that's a source of wonder. To me, it's a source of wonder.
Oh, yeah, me too. Yeah.
Thank you.
Whether there was, Randy and I have had many discussions about whether there was actual divine intervention, intentional intervention. That's something that science can't answer. But recognizing teleology is in that direction.
Marty, thank you so much for that question. That is so fruitful, and it gets us into the question of agency and agency for theists and for those of us of faith. That means it's the God who stands behind, and not only stands behind, but is under, in, around all of this wonderful creation that he sustains moment to moment. That is what the great creeds of the church say. That's what the ASA has been founded on, what brings us together for these conversations. It's been a great conversation today. Love to keep this going. Little self-promotion here. I actually put in the chat a book that's by Pierre Durand on the evolutionary origins of life and death. And the other end of the question is the one that I have spent my time doing research on. It's not nearly as well developed as the abiogenesis side. When as we saw today, abiogenesis is just starting to really open up some just getting started. And but it's really, there's two sides of this. Some theologians and ecological ethicists have said you have to clear death back in order for life to flourish. You've got to have a space there for this to happen. And we just don't have we have virtually no theory about death. We just know it as enemy. We don't have theory about it and how it works. We just have terrible definitions that keep sliding on us. But abiogenesis, I think, is really pointing the way. So Randy, Stephen, again, thank you so much for these 3 articles, for your clarifying so much for us. Thank for the wonderful questions that came in. This has been a very fruitful series, and it will continue in the ASA forum, as we have said before. So you can go to that site here in the next week or so, and the forum will open up quickly, and the recording will be there, and we can continue this discussion. Don't forget, register for the ASA meeting in Toronto. It's the 50th anniversary of the CSCA, our sister organization, and be sure to be with us next month when Randy is back in this chair, the host of Diving Deeper Discussion. Thank you all, and have a great day.